Okay, here's a 6.3.2 practice. Determine if a triangle with a set of side lengths is right, acute, or obtuse, if possible. And there's 8, 5, and 4, 5, 3, and 2, and 10, 7, and 8. And pause. Okay, right away. So in all three cases, you want to always identify the biggest side, right? So we'll do that in each of these cases. And then the question is, is 8 squared, and what's its relationship to 5 squared plus 4 squared, right? That gives me 64 as it relates to 25 plus 16. And 25 and 16 is 41, right? And so since 64 is greater than 41, this is obtuse. On this one, we look at 5 squared, and we look at 3 squared plus 2 squared. Oops, didn't mean to do that. Move everything back. And I look at 5 squared, so we end up with 25 on one side, and we end up with 9 plus 4. Now, this becomes 13, and you might be tempted to say that it's obtuse. What you have to be super careful of is, if you remember the triangle inequality, this is an illegal triangle. Maybe I'll even put it in blue. Illegal triangle, okay? Because remember, the two sides of a triangle have to be greater than the third side. So 3 and 2 has to be greater than 5, and it's actually equal to 5. So if you tried to build that triangle, right, let's say this is a length of 5, this is a length of 3, and this is a length of 2. Remember, you can't get a triangle out of that. And so it's an illegal triangle, even though it looks like it may have been obtuse. So be careful there. In the last example, this is a legal triangle. We have, right, 15, we've got 17, and we've got 18. So they're all perfectly fine. And we're going to look at 10 squared as it relates to 7 squared plus 8 squared. That gives us 100 on one side, and the other side is 49 plus 64, which hopefully to you clearly looks like more than 100. So we are at an acute triangle on the last one. Okay, hopefully you got all those.